Alright, what are derivatives? So a derivative is the instantaneous rate of change. So what does that tell us? So imagine you have a graph, right? Or imagine you're driving a graph. I'm going to draw a graph time representation of driving a car, for example, in physics. So the derivative is different from the slope. So the slope is just the rise over run, and it happens, usually it could take its time. But a derivative is instantaneous. Let's say that you want to find some values using the derivative and they're very close. So derivatives are a good way of approximating the instantaneous rate of change at a very given moment of time. So you're specifying when it's going to happen and how fast it's going to change. Alright, so that's the idea of a derivative. So I'm gonna go over here. I'm gonna write a couple down formulas that you might need to know. And as an example, we're gonna use one of these formulas. So the first formula, or the definition of the derivative, goes as following: the limit as h approaches 0 of f of x plus h minus f of x over h. So that's the generic formula that defines the definition of the derivative. A couple other formulas, and I'll talk about these in a couple other videos, is the power rule. The power rule is another big one. So you have the d over dx notation. Let's say if x to the n. So the derivative of x to the n, what you're going to do here is going to move the n in front of the x. So this is going to be n times x, and it's going to be n minus 1. So let's say that it's the derivative of x to the fourth. What I'm going to do here is I'm going to just simply move the 4 from the x and then subtract 1 in its exponent form. So it's going to be 4x cubed. Alright, so that's a couple ideas of derivatives I want to introduce to you, and I'll do a couple examples of this problem using this formula in this video. Alright, do this problem. So the function f of x is 5x plus 3. Find the derivative for f prime of x. And in this tutorial right here, in this example right here, I want you to use the formula, the definition of the derivative formula, with the limit as h approaches 0 of f of x plus h minus f of x over h. Alright, so I'm going to apply this formula to find this. Alright, so how am I going to do that? So we know that you can't just plug in h as 0, because notice how there's an h on the bottom here in the denominator. And then you know any number above 0 or divided by 0 is undefined. So that's out of the picture. So I'm going to have to do a bit of algebra here. So first what I'm going to do is I'm going to identify what f of x plus h is. So f of x plus h, turns out that what I'm going to do here to find that is this. So notice how we have a 5x, right? So what's going to happen is I'm going to just enclose the x inside the parentheses right there. And we'll keep the 5 and the plus 3 separate from it. So f of x plus h is going to be 5 times x, and make sure you put the h, plus 3. That's f of x plus h. F of x, as we already know, is just going to be 5x plus 3. Alright, so now what I'm going to do is I'm going to plug this into the formula. So I'm going to rewrite the limit expression. The limit is h approaches 0, and it's going to be 5 times x plus h plus 3 minus, and inside parentheses, we have a minus there, 5x plus 3. And that's going to be over h. Alright, so now what I'm going to do is I'm going to distribute the 5 to which side those parentheses, and then negative in which side those parentheses. So it's going to be the limit as h approaches 0, and it's going to be 5x plus 5h, and it's going to be plus 3 minus 5x minus 3. And that's going to be over h. Alright, so now what I'm going to do is I'm going to be able to mark out some terms. So I got a positive 5x and I got a negative 5x. So I'm going to mark those out. I got a positive 3 and a negative 3. So I can mark those out. So I'm left with the limit as h approaches 0 of 5h over h. So notice this. Now if I plug in the limit now, it would still be undefined. But now a property of algebra we could use is we can mark out the h terms. Just like that. So actually this, we could disregard this. Make sure you do write the limit every time you do these though, because when professors ask you to show your work, you want to make sure you're doing it right. So the actual derivative of this whole thing turns out to be 5. And now notice this. But why is it 5? Why is it 5? Why is it not 5x plus another number? So if we break this down into parts using the power rule, which I'll show you real quick. Let's say I use the power rule, I'm going to apply it here, right? So the power rule is n times x to n minus 1, right? If you want to find a derivative. So the derivative of 5x, for example, using the power rule, what I'm going to do is I'm going to write 1. So what's going to happen is I'm going to move the 1 from the 5. So it's going to be 5 times 1. And it's going to be x to 1 minus 1, which is ultimately just going to be 5. So you basically what you're doing is just taking away 1 from the exponent there. That's exactly what you're doing, and you're moving in front of it. So another thing you want to know, another rule you want to know, is the derivative of a constant like 3, 7, 14 is always going to be 0. So that nullifies the 3. Therefore, that's the reason why the derivative of this expression right here, 5x plus 3, is just 5. Alright, how about this? Find the derivative of x squared. Alright, so how am I going to do this? So in the last example I showed you how to use it using the power rule, and I showed you how to use it the derivative formula of the other function. So in this one I'm going to redo this. So I'm going to do this one with the derivative formula. So the limit as h approaches 0 of f of x plus h minus f of x over h. Alright, so that's the formula I'm going to use to solve this one. Alright, so what I'm going to do here is I'm going to quickly identify what x plus h is. So f of x plus h is actually going to be x plus h squared. Because notice this. Notice how we have an x, right? In the last example, I had 5 and I had a positive 3 in front of it. And then I had the plus 3 afterwards. So it's just going to be x squared because all you do is just substitute this for the x squared. And the f of x is just going to be x squared. Alright, so now what I'm going to do here is I'm going to just put this into the formula. So I'm going to go and proceed with that. So the limit as h approaches 0, and it's going to be x plus h squared minus x squared over h. Alright, so now what I'm going to do here is I'm going to expand this right here with inside that parenthesis. So it's going to be the limit as h approaches 0, and it's going to be x squared plus 2xh, and it's going to be plus h squared minus x squared over h. Because the reason why I did that is because if you use the formula a squared, it would be a squared plus 2ab plus b squared. Using that formula, I quickly did that. So what I'm going to do here is I'm going to mark out terms now. So notice how I got a positive x squared and I got a negative x squared. So those are going to mark out, so that's out of the picture now. So I'm left with the limit as h approaches 0, and it's going to be 2xh plus h squared over h. So I'm going to have to do a little bit of algebra here. I'm going to have to pull out the GCF here in order to get this, because I cannot just plug in 0 right now. So what I'm going to do is I'm going to pull out an h out of this, the numerator. Alright, and the reason why I'm doing that is I'm going to pull out, it's going to be h times 2xh, or 2x, not 2xh. It's going to be h times 2x plus h, and then over h, and then make sure you rewrite the limit expression. So now what I got left of is this. So since I pull out an h from this right here, all I'm going to do is I'm going to mark out the h in the numerator and the denominator. So now what I'm going to do is I get to use direct substitution to solve this limit expression now. So the limit as h approaches 0, and it's going to be 2x plus h. So h is 0, it's going to be 2x plus 0. Therefore, the derivative of x squared is going to simply be 2x. And just to show you quickly the quicker method of doing this, I'm going to use the power rule. So let's use the derivative notation, d over dx of x squared. Using the power rule, I'm going to move the 2 in front of the x. So it's going to be 2x, and it's going to be 2 minus 1. And this, you get the same exact answer using the power rule. I just want to show you both ways. I want to show you primarily this formula in this video and how to apply it, the difference quotient. So if you found this video insightful for a pre-calculus class or calculus class, be sure to follow for more content, subscribe for more content, watch out for more videos. Thank you for watching. Y'all have a good day.